Hello? Test. Can you hear me over there? No? Get closer. Okay. All right. Hello, everyone, and welcome to MPLS IETF 124 session. Myself, Tariq Saad, I'm chairing this with my co-chairs, Tony on my left and Adrian on my right. We have our secretary, Mac, usually is participating remotely, and hopefully he'll be able to join us today. Test. Okay. All right. Again, welcome everybody for joining and contributing to our working group. Okay. This is IETF, and you're participating in it by now. We're Friday, and you've seen this note well multiple times, hopefully, most of you. It's a reminder of the processes and policies that govern IETF contribution and participation. Please get acquainted with it, yeah, when you have time. These are some useful links about our working group. Specifically, I encourage participants to check our wiki, where we have the status of our documents and raise issues with the chairs if you see anything out of sync. This is not helping. Okay. Today's agenda, we have 8 items on the agenda for a total of around 85 minutes. Our session is 90 minutes. So we highly encourage the presenters to be on time, stay on time. We'll try our best to remind them as well from our side. Feel free to raise any issues on the agenda now or forever. Hold your breath. Oh. Back.
No, on the right side. So we're reversing the order of items 5 and 6 so that Zafar can run out and go to 6-man.
Okay, thank you, Adrian. Okay, nothing else on the agenda. A status from our side. There's no errata since last IETF that we met. There is a liaison that came to multiple working groups, including MPLS. We'll be coordinating, the chairs will be coordinating with other working group chairs to see if a response is needed. Sorry if my voice is not loud enough. New RFCs since last time we met. We have a new one, and I want to thank the working group and the authors for, as well as whoever contributed for putting the effort on producing this. We don't have any RFC in the editor queue at the moment. We do have one document that was produced by the working group, and we sent it to IESG. This is a base document for the M&A solution and will open work for other documents or open path for other documents. So thank you again, working group, for collaborating on this. We do have a new working group document. It got adopted back in August, and I believe it is on the agenda for, no, this is just got adopted and it's not on the agenda for today. We have 2 updated working group documents. One of them was close to getting published. The authors are still working, specifically the MLTP Yang document. The authors are working with the reviewers to address comments. We expect one last revision, and then we'll go for working group last call and progress this document. The next document, the PS header, M&A PS header, It is a work in progress at the moment. Some documents without update since last time. The NRP selector, it is on the agenda for today, and the authors have promised an update soon on this one. We have the MPLS stamp pseudowire, which is on the agenda for today. There'll be a good discussion on this one. And the M&A IUAM document. Some individual documents, many of them are on the agenda for today. And I'll just skim through the rest. And we encourage the authors to revive if it is expired drafts, if there's still interest in driving those drafts, and ask the chairs for help if needed. And I think that's the end of our status report for today. Feel free to come to the mic if you have any questions or concerns to raise. No questions. So our first presentation will be Tony for the M&A NRP selector. Please go ahead. It's a bit not cooperating sometimes.
Good morning. There have been no changes to this document since adoption and no comments on the mailing list. The chairs have asked me to review this as we go into working group last call. The goal of this document is pretty straightforward. We want to carry an NRP selector, and we want to do it inside of ISD. In this draft, we are proposing carrying 13-bit and 20-bit NRPs, and then we also support an 8-bit NRP with 12 bits of entropy. If you want to carry 13-bit NRPs, we propose doing this. This is used as LSE format B. This gives us minimum overhead and gives us 8,000 NRPs. The figures in this talk and in the draft are not in sync with the current ISD draft. Apologies, that's on me. We will be updating the draft next week. If 13 bits aren't enough for you, here's another way of doing it with 20-bit NRPs. This causes us to use a format C LSE, and so it consumes a little bit more space in the label stack. And finally, if you can deal with only having 8 bits of NRP, and then you can also have 12 bits of entropy and do both at the same time. This is covering the common case where you have NRPs and you need ECMP. So these are the 3 things we're proposing. So far, come to the mic, please.
For lease Cisco systems. So there is multiple encoding here. You said that there's no comment. These comments were passed during adoption that maybe as a group we need to merge into fewer options. This will only create problems in interop. One vendor implemented one, the other implemented the other one, and this is all of that thing will be down the pipe would be an issue. There's also PSD, and that's 32-bit. So now we have actually 4. So that's a concern that was raised during adoption, and I don't think this has been addressed because you still have this thing. So I just wonder what is the plan, even you as the author, as we as a working group, to try to merge to a fewer or maybe one preferably option.
So there's no comments after adoption. All of those comments were prior to adoption, and nobody has raised those again. Frankly, we don't see this as a problem. If an operator has 1 million or 4 million NRPs, they're welcome to deal with it. Our informal conversations with carriers strongly suggest that they can't manage that many NRPs anyway. They're more likely to do about 50. So 8 bits is probably sufficient. So if you want to actually trim this, and I'm not objecting to that, but I need to hear that from the working group. If you want to trim this, the thing that I would do is to trim the longer ones, because we don't need those.
I tend to agree with you that the read, at least for me, is also that we don't need that many, like in like 32-bit or even 20-bit is way too much. That leads us to fewer ID, more compact size and all. But yeah, I think this is a discussion the working group needs to have. And there is a parallel conversation that is going also happening in 6-men. There is a question on the same one. So I would also like chairs to do a little bit of like help in terms of coordinating, because this can create problem in interworking as you go from one IPv6 to MPLS and vice versa. And I think it'd be good for us to like converge, because then it will be just creating problems for interrupts.
Chair hat on. I don't see what you're asking. Chair hat off. I don't see how this has got a problem. Operator picks whatever width they need.
I disagree with that. I think we need to, if you want operator, like ask does operator need 1 million NRPs and how are they going to manage this? I don't see it happening. Operator asking for 1 million NRP, how? I mean, NRP is something, and the management plane is an instance in the management plane. So everything happened within that instance. So I don't see it happening. So I'm happy that we've converged on a shorter size. But having too many options, it just makes room for any future. Like we're putting seed for future problem.
Thank you for your comments. I respectfully disagree.
Can I ask Zafar, are you suggesting that implementers might only implement part of a standards track RFC and that could then cause problems?
What do you mean?
Well,
Yeah.
when you're saying that there might be an interop problem between different vendors, some have used one length and some have used another length, that would mean that they've only implemented part of the RFC.
It happens all the time. I mean, I'm not going to burn hardware like doing a 20-bit version, 13-bit version, and an 8-bit version. It's
Anyone implementing this in hardware is smoking something, okay? Modern NPUs are all microcoded.
Okay, I mean, all I'm asking is that we as a community need to think, and operators, you ask for operators may be doing it. This is the question. Okay, what should be the space? Okay, I mean 20-bit, 32-bit NRP is completely out. I mean, how you going to manage this? So at least start with that. Can we remove those options, and can we do something consistent? So interop would be an issue. Like, how do I take a 20-bit and put it in 8-bit?
Well, see, here's the problem. There are some people out there, notably 5G proponents, who will tell us that they're going to have 1 million NRPs. Now, I think they're smoking something, but there are people who have that opinion.
5G NRP get mapped N2.1 into transport NRP. Just because there could be some notion of these, and this is a data plane instance. This is not a control plane instance. This is a data plane instance. So 5G may have like some other instance. I don't know. I'm not 5G literate, so I cannot comment that. But if I have 1 million coming in, I will map it to a few as the traffic comes in my transport. So in transport, we have to see what can we do. It's not that because 5G has some other construct and we just map into a data plane construct in our transport. No. Anyway, I think the discussion needs to happen on the mailing list. The comment that was given is still unaddressed.
Pawan Biram, HP. This is regarding having different formats in MPLS and in 6-man. I think that's perfectly okay, as long as the handoff points in each NRP domain understand what the policy is. There is really no requirement that you need to use the same format in MPLS and in 6-man. There is a control plane identifier, which is 32-bit, and that needs to be consistent. But we are talking about pushing NRP policies everywhere. So, I mean, that was the discussion that happened earlier. If you want, we can take it up on the list.
No. We have a queue, and you've had a long go.
Yes. Hi, Greg Mirsky Erickson. Thanks to Pawan. I think that if any discussion should happen in TS, not in MPLS or 6-man group, because yes, as Pawan noted, there was discussion on TS, and TS decided their different sizes of NRP identifiers, and if they want to restrict to smaller number of options, so probably it's better to have this discussion in TS. And then data planes will just follow.
Matthew Bocci, Nokia. Yeah, I agree with all the people who said there's too many options. I think we need concrete use cases of why we need all these options. And it's not just an implementation issue, it's a testing issue.
Thank you. Any more questions? All right. Thank you.
Okay, well, next we have Rakesh. Rakesh, I can use this. It might help.
Thank you.
Yeah, good morning, everyone. My name is Rakesh Gandhi from Cisco Systems. I'm presenting the draft on stamp encapsulation for MPLS on behalf of my co-authors. So agenda is look at the requirements and scope of the draft, a couple of discussions that happened over the mailing list, and next steps. So the requirements is the stamp encapsulation for MPLS, MPLS-TP, LSP pseudowires with various MPLS has various headers. So encapsulating them in such a way that it follows the same path, ECMP path with phase sharing as data traffic. And scope is stamp 8762 and 8972. Just a reminder for stamp, this work is done in an IPPM working group. So TWAMP has been around for a long time as RFC 5357. It uses control channel signaling, and IPPM working group decided to simplify this and remove the need for control channel signaling to bootstrap the session. And that's how the simple TWAMP simple two-way active measurement protocol was born. So it's a simplification. And then the extension for SRMPLS were defined in IPPM working group in RFC 9502, specifically MPLS return path, stamp TLB, for example. So first discussion is about the encapsulation. So the IP-UDP is already covered in 8762 and 8972 RFCs. And then what would it take to encapsulate those packets in MPLS networks? So we define many different encapsulation formats. There were three discussions that at least I was able to capture. One is about using the destination address in the IP header of the stamp packet. Routable as well as non-routable IP addresses are supported, and we have shared a working copy with the proposed text for it. Another discussion about what happens in those two IP address cases when packets forwarded over broken LSP. So basically, as we see in the requirement, that stamp follows the data traffic. It's the same encapsulation that's added by the ingress node for the stamp packet. So if data traffic is dropped, then stamp packets are also dropped by the broken LSPs. But there are a few cases that's also in the proposed text that's shared, as well as it's in the appendix of this presentation. And another comment about stamp packet not leak outside MPLS domain is the same thing. Stamp IP packets, what happens to the IP packets in the MPLS network happens to the stamp. It's the same mechanisms, security mechanism, filtering mechanism for IP packets in MPLS network apply to stamp as well. Second discussion point about the LSP ping work for stamp. It's defined in draft MERSQ MPLS stamp. It's a control plane signaling to bootstrap a stamp session. It's an optional mechanism. It's specific to stateful mode of a stamp reflector. There is an alternate mechanism defined in 9503 for stamp return path TLB. So we could progress as a separate document. So next step, this is proposal. So for the first discussion, there is a text shared on the mailing list, as well as in this presentation, we can review this, the text and update the draft. Second discussion is progress the LSP ping, optional mechanism to bootstrap the stamp session in a separate working group document. Once this is settled, then we do believe the document is ready for working group last call, and welcome your review comments and suggestions. Thank you.
Flip to the other one and then take questions.
Okay.
Okay, so
We'll switch to Greg and then
okay.
we'll take questions.
Thank you.
Thank you. Okay, actually, there is a, well, this draft has been in a working group adoption poll, and it has been adopted, so it should have been changed the name. But I present you the snapshot of this work and the discussion what we had with the authors of the draft Rakesh presented on the mailing list, and what is we believe is a fundamental issue of the discussion. So the simple active measurement protocol, it uses echo request, echo reply mode for the tradition and established by IPPN working group. This is called a reflector. So it's a reflector packet, and in the stamp, because it uses TLV, it's been interesting for other developers to propose different extensions, and the number of documents being submitted, already some of them published for IPPN working group and other that extends the basic fundamental document and the mechanism that introduce in IOC that introduce 8972, the extension mechanism. So the stamp in MPLS. So LSP ping has been used to do the bootstrapping as different OEM protocols and optional mechanism. So same here applied to communicate the stamp session ID and destination UDP port if needed, because one option is to use well-known port 862 as shared with the T1 protocol, but at the same time to hide this OEM packets, they might use UDP port from the dynamic port range. So this man in the middle would not understand where their what is their packets, and would not be able or have a harder time to do some damage, affecting and skewing their measurement results. In IP-UDP encapsulation, what is proposed is to use for IPv4 address from IPv4 loopback that has been established from the I believe, 4376 RFC that had been updated by 8029. So because basically what we need to have is, as stated in section 2.1 of this RFCs, that clause 2, the MPLS OEM packet must not escape MPLS network. So thus it was updated that packet with a loopback address can be sent, but not as a destination IP address, but as a destination address in the tunnel. For a while, we had a misconception, at least I had a misconception, that IPv6 mapped IPv4 loopback addresses are appropriate to use for the same purpose. That was misconception. It was wrong because these IPv6 addresses are routable addresses. So IPv6 has only one loopback address. And in some documents, we recommended using this single address. It has some inconvenience because, as you see in IPv4, we have a range of addresses to select to. So thus, if the payload of MPLS used 5-tuple to generate entropy, it can be done using variating this selecting IP address for the black magic. So what was proposed to create a dummy IPv6 range so that the same technique can be used for IPv6 if somebody doesn't use flow label for entropy. So that's what is proposed in this document. For IP UDP encapsulation of stem packet in MPLS LSP, select IP address from IPv4 loopback range or IPv6. Why it's important? It's not for the case when the link, the downstream link is down. It's when there is disconnect between the control plane and data plane. So when the transit node believes that this is the node to terminate the LSP. And that's explicitly being stated in RFC 8029 as the reason for this precaution. So there might be, because LSP ping is a tool to verify the consistency between the control plane and data plane by sending the target FAC information. But at the same time, so what might happen is, as you can see here, so the normal case, we encapsulate stem packet in IP UDP and then MPLS stack. It's being sent from the session sender to the session reflector, and it receives this packet intact. So that decapsulates MPLS. It finds that the destination port address is a loopback address or IP dummy address. It removes this stamp packet, stamp application reflects it, and then sends it accordingly. So it can send it over IP, or if that's instructed, it can send back over associated LSP or the control path that's being provided. But if a node B has this misconception that it is a terminating node for the LSP, then their MPLS stack will be removed and IP header exposed. In a case that IP destination address in this IP header is routable, this packet will be routed. And that goes against the requirement in RFC 8029. So because this is MPLS OEM packet. So this packet should not be routed. If the case is that stem packet originated by a node outside of MPLS domain, then for the MPLS, it would not be considered an MPLS OEM packet. It will be just a data packet. Yes, for that case, it's absolutely legitimate that such packet maintains its destination address of the session reflector. Even if the session reflector is the terminating node for MPLS domain. But if it's generated as MPLS OEM packet, it must not have routable IP address. And it must not be routed out of MPLS network. And that's it. Any questions?
I have a question for you, Greg.
Yes.
So Tarek, a working group chair hat off. So you say there is a requirement that it must not be a routable packet.
Okay.
But you didn't quote this requirement.
Okay, the requirement does not routable. The requirement is that the MPLS OEM packet must not leave MPLS network. So how that achieved?
But here in the example you gave, it did not leave.
Well, if the IP address of MPLS OEM packet, or if stamp packet that encapsulated IP UDP in MPLS is either for IPv4, one of the address of IPv4 loopback range, or of IPv6 dummy prefix, then this packet will be dropped.
The example you gave, it reached the destination, right?
No, example on the right, it would not reach destination. Because again, this is not the case where the link is down. It's the case where there is a misconception that in this example, OSRB terminates the LSP, even though the LSP is expected to be terminated on session reflector. And that's explicitly noted in Section 2 of RFC 8029 as the case why it's important, because there might be an inconsistency between their control plane state, and data plane state.
Okay. And last thing is, to be clear, that data traffic is actually following the same path in this case as the stamp packet.
Well, again, right. So the data entering the MPLS domain, if it maps to the same LSP, yes. And actually, yes, it will be unfortunate. Well, again, we use OEM tool and LSP ping for the purpose of monitoring and verifying the consistency between control plane state and data plane state in MPLS. So we cannot do it on a data packet perspective. So yes, this data packets that enter in this domain, they will be routed from, in this case, from OSRB, and that's up to the operator to use OEM tools to monitor and detect it, this anomaly, and mitigate it, right? But adding that to the problem by using routable IP address to MPLS OEM will make it non-conformant with RFC 8029.
Okay, thanks.
Hey, Greg. Footer with Nokia. I want to make sure I captured something correctly. If the IP packet is being resolved to an MPLS tunnel, like a data packet coming into the MPLS network, not validating the MPLS tunnel, then that can carry a destination address that's unicast.
Yes.
Okay.
Again, because
It's data traffic.
yes, it's data traffic. Yeah.
Perfect. Thanks.
The RFC 8029 and its predecessor, it's only about their packets that being IP UDP encapsulated for the purpose of monitoring MPLS network.
Tony Lee, HPE, chair hat off. Could stamp packets be sent in an MPLS network if VPNs are involved?
Yes, but probably, it's like then we'll be measuring within context of VPN, yes.
Okay, so then in the case on the right here, when B decides to route that packet, which address space is he using?
well, then it would basically will use whatever IP address is there. So if it doesn't know this IP address, then it drop it. But there is no guarantee that it doesn't know this IP address.
Okay, but could those IP addresses overlap between VPNs?
Yes, and that's even worse.
Okay.
Well, again, but my ambiguity probably it's making the situation worse. Okay, thank you.
Rakesh, did you want to say something? Yeah.
Rakesh Gandhi from Cisco Systems. If you go back to a slide where there is a bootstrap where it talks about, so TWAMP has control channel to bootstrap the session ID, destination port, and source port, and that's how you bootstrap TWAMP sessions in 5357. Stamp removed that. So if you want to do the bootstrapping of Stamp session, maybe it's an idea, if that's a requirement, to add a control channel for Stamp and do the work in IPPM to say, I need a control channel to similar to TWAMP to bootstrap this session with session ID, destination port, source port, and now it will be generic for Stamp and nothing about MPLS. Just my comment and something to think about.
Yes, thank you. Again, as noted, so this is an optional mechanism. So this is not required because like bootstrapping other things with using LSP ping, it's an optional. So if okay, thank you.
Thank you, Greg. It's Shuyan. Shuyan.
Yes.
Slides are being worked on. Patience, please.
Okay.
Thank you. Please go ahead.
Okay. Yeah. I can't control it. Okay. Okay. It's Xueyan from ZTE. I'd like to have a try to control. Now I control to the slide 2, but I still see the slide 1. Right?
That's really funny because we see slide 2.
Okay. Thank you. Okay. I'm it's Xueyan Song from ZTE, and I'm presenting the MPLS network action for deterministic networking. This draft is a merge draft, and which replaced these 2 drafts. And this draft is from ZTE Ericsson and Cisco. The first draft is about, M&A deterministic latency. This draft introduces MPLS deterministic latency network action opcode to support .NET. And actually, it defines the opcode and related auxiliary data to carry the latency specific information. And for the second draft, the MPLS .NET M&A, this draft provides a generated flexible M&A solution to support .NET. And it uses the .NET parameters. These parameters are compatible with .NET MPLS traditional, the traditional .NET MPLS data plane used. These parameters include flow identifier, sequence number, latency information. These two drafts actually we have presented for several times, and we have many discussions on them. We also received many feedbacks from the chairs, experts, many SACs. And after the IETF 123 meeting, the co-authors decided to make merge to these two drafts, and because these two drafts had some overlaps, and but they may have different focuses and some similar solutions, so we made a merge to these two drafts. And for the merging, to these two drafts, first, because the draft 2, this draft is from Ericsson. It uses a more generic solution to carry the .NET information. So we decided to use draft 2, this draft as baseline, and also make some enhancements to support the deterministic latency, which raised in the draft 1. For the merging content, we also make a combination of these two drafts. Use the draft 2, introduce the .NET specific M&A framework, and use its design, and also make combine this deterministic latency raised in the draft 1. And except the contents introduced in the original draft 1, draft 2, in the merge draft, we also made some enhancements, except to the ISD solution support, we also add the PSD solution to add the flexibility of the solutions. For the solution overview, we use the M&A to encapsulate .NET specific parameters. The first one is about flow ID. This parameter is used to identify the .NET flow, and this flow can include the single .NET flow and also include aggregation .NET flow. A sequence number is used to perform PRUF action, and latency information. This parameter used to perform latency related action. And for the solution design, we use the same format, encapsulated for the ISD and PSD. And for this solution, it also, also support the flow aggregation. This figure shows an example for ISD solution, to support .NET. And from this figure, you can find there are 3 opcodes are designed, are introduced. First one is the opcode to the latency information, flow ID, and the sequence number, and it can be used to aggregation. Flows can also be used to single .NET flows. And for the latency information, it may be not has a fixed length, so it may use format B plus C, or format and for the flow identifier, it it's designed as 20 bits length. It can also be used for flow of format B or format B plus. Yeah. And for the sequence number, it has 16 base length or 28 base length. So it can also has some optional formats. And for the PSD M&A encoding, first we use the ISD header, through the P set to 1 to identify the PSD header in presence. And because the latency information field may use a variable length field, so we also introduce PSD solution. And for the PSD, for the PSD format and the ISD format, actually we use the same format, through the same format design. It can improve the design simplicity and improve the scalability for this solution. And for the IANA consideration, we request these 3 parameters used for the DNS support. And this opcode are used to both in-stack and post-stack. Request the working group feedback, your question and comments, and also request working group adoption. Thank you.
I have a question. This is Tarek, and working group chair hat off. Thank you for the work. I see that you presented 2 solutions for the same use case in the same document. Not sure what is the signal for an implementer. Are we suggesting, recommending to implement solution 1 in certain use cases? Any recommendations in the document? I didn't see them, if there were any. Should both solutions exist in the same document? And thank you again.
Tarek, if I may, as a co-author.
Yes, please go ahead.
Okay, Shuyan, this is Greg. I'll take this. We've done it based on history of merging IOM document that was recommended by chairs to have a solution that uses M&A in-stack and post-stack. So we just took this initiative to reduce the number of documents because the 2 documents addressing the same problem space. So then, yes, we are open for the recommendation and discussion by the working group.
Okay, thanks, Greg. I do remember the IOM discussions, and there were clearly 2 use cases then that were presented, the passport and mode.
There is an overlap in that because basically because I was co-author on direct export. Yeah. So basically there is like in-stack data. Direct export is a subset included in what can be covered by post-stack data, but the attractive part of it, the benefit is that because in-stack data is more efficient, and for some scenarios, like in a mobile network, direct export seems to be a preferable mode of using in situ OEM. And actually preempting this, I can point that another document that's not being discussed today, but we presented in Madrid, it's ECN functionality in MPLS network, again, using M&A, and there are two possible solutions for in-stack and post-stack. So we'll be extending this work. There is something that we need to do for the next version, but planning to bring it to working group and again to discussion. So probably we'll have several documents that will provide solutions using both in-stack and post-stack.
Yeah, I appreciate that feedback. I'm just concerned that wherever use case we're trying to solve, now we're presenting two solutions for it, and then the implementer is confused. Which one should I implement? Both? One of them? When do I implement the first or second?
I agree with you. This is a very good question to discuss. And again, in my opinion, in-stack, if possible, it's almost preferable. But again, people have different perspective. Thank you.
Rakesh Gandhi from Cisco Systems. IOM has one document for both, but then NRP has two separate documents for in-stack and post-stack. And my personal preference is also to have separate documents for in-stack and post-stack. It's a bit cleaner and it's easier for implementer to say, I support this RFC and that RFC. So I think, but it would be good to get guidance from working group to say, let's have consistently separate documents for in-stack and post-stack for all use cases. But otherwise, it's always going to be confusion. Thanks.
Makes sense. Thanks, Rakesh. We'll take it with also the shares. And we have Joel next.
Joel Halpern from Ericsson. I would put it a little differently. We have had a lot of trouble with people arguing about whether something belongs in post-stack or in-stack. That has not helped us. While it is a pain for us to have two solutions, it is much more of an obstacle to spend a year arguing about whether we should have solution A or solution B. And it is much clearer to everybody that we're doing both if we do both in the same document. I don't care if we do two documents if everybody's comfortable, but it tends to make things clearer to everybody when we choose to put them in one. That's why one of the other drafts I've co-authored, we did both, because if I left one out, the immediate question would be, why didn't you do that? Whichever one I left out. Well, let's not ask the question, just put it in. That's where I'm coming from.
Thank you. Okay. Who's next? Zafar. Yeah, Zafar, and Pointer is right
there. My name is Zafar Ali. I'm presenting on behalf of this draft that is co-authored with folks from HPE, New H3 Technologies, and Huawei. So I will explain the problem statement. So what I'm sharing with you is the FAQ, the MPLS ONM FAQ from RFC 8287. And this is to be able to do data plane versus control plane validation in SR when using for us giving IP prefix. Now, we have support for flex algo and multi-topology, and that entity or the signaling of that either the multi-topology ID or flex algo ID in the ONM FAQ is missing, and this draft tries to address that. So proposed solution is very simple. You basically take the reserve section, and in that reserve section for either IPv4 or IPv6, there are two different FAQ TLVs, carry the algo. The rest of the processing at the box doesn't change because we have across the board different FAQ that sorry for that. So we have different FAQ that we carry, and the procedure doesn't change when we add a new FAQ, but it's really being able to verify that this particular SID label belongs to a specific algo or same thing for multi-topology. So I'll give you a little bit of the history of the draft. So this draft started earlier, and it was presented in the meeting as well. But at that time when we started this, some of the authors that are also author of this draft went on a different direction of defining an egress validation. This did recently become RC 9655, and then we were approached by multiple people that there is a need to plug in this gap. So we extended the MILFAC notion so that you don't have to add individual FAC every time you have a change in data plane or you're modifying or introducing a new feature in MPLS data plane. So that's for that reason we extended the MILFAC with some option that's 9655. But because we were approached, we did revise the ID, and that's the reason of this being here. It was presented in IETF 123. Sorry, it was asked for a slot, but IETF 123, last IETF, MPLS agenda was packed. So we did send update based on chair's recommendation to the mailing list, and there was a lot of comments and corroboration. And we worked with the folks that have commented, and some of them are corroborating on the draft as well. And we have addressed all the comments that were received. Well, we welcome any additional comment on the draft, and we would like to request the working group to adopt this work.
Michael Gorchowski, Ribbon Communication. First of all, very useful.
Could you stick the microphone up your nose? Yeah.
This way?
Thank you.
Okay. Okay. Closer. Okay. First of all, very useful draft. From my point of view, shall be adopted. I have had some question or comment. If you look to original sub-TLV for target FAC, you are reusing reserved bits and reuse it for algo. My question, are you going to use the same subtype for the sub-TLV, or you suggest a new one?
No, new subtype.
Okay, if you're suggesting new subtype, it shall be and depreciate this one. It shall be
No. This is deployed. This FAC is deployed. This is yeah.
Okay, so in order to use algo in this subtype, you are suggesting new subtype, and this subtype will be used also for default algo as well for non-default algo. Now, the existing sub-TLV will exist and used. So it is a suggestion. So look, you are using the same name for sub-TLV that called prefix SID target FAC. And actually, you will have two subtypes, existing 34, I'm talking about IPv4, and new one with the same name that you're asking for new subtype. So, or you shall change the name, or we will say that previous one will be depreciated, as we are usually doing with this. So at least for me, it was not clear.
I got it. No, we change the name. That's perfectly fine. Please, suggest anything and we change the name.
Okay, so we may continue.
No, if I'm done.
We have two options. Okay.
Yeah. No. We change the name. Yeah,
okay.
Because this is deployed for backward compatibility. We cannot just change and depreciate this.
Because we will implement it. Because actually today we have nothing interoperable with flexible.
Welcome your feedback and happy to talk with you offline and take any comments and corporate.
Just want to make a comment, nothing to do with the drafts. Just so everybody understands in the room, those doors don't work. And it's very distracting because lots of people, when they want to try and exit, are going over to those doors. So if you have to go out, use that one.
No comments.
We have one more question, Zafar, from Yao.
Yeah.
Hi, Zafar. I'm Yao from ZT.
Hi, Yao.
As I comment to the list, I think it's a very useful draft, and considering that besides prefix set, the adjacency set can also be related with a flex argo, and it can also be related with multi-topology information. So, will this draft consider the sweeping for the adjacency set in the future?
I'm having some difficulty understanding the full question. If somebody understood, I'm happy to.
Can you repeat the question again, please?
Okay. So besides the prefix set, and the algorithm, the adjacency set can be also advised along with the flex algo, and the adjacency set can be advertised along with the multi-topology information. So besides currently this draft focus on the prefixes side. So will there be any consideration for the sweeping for the adjacency set with flex algo or multi-topology information in the future?
I think that's a very good comment. I welcome your feedback on this. The answer is yes. You're right. That is not only prefix set. This could be adjacency set, and so let's work maybe a little bit offline. Maybe you can suggest some improvement or addition of the additional fact. What you're asking for, adding additional fact, so we can work offline on this.
Oh, sure. I'll be happy to do that.
Thank you.
Thank you.
Thank you.
Leanne is next.
Yes, I'm online. Okay, I can see it. Hi everyone, this is Lian from China Mobile, and together with my co-author Chang Wang. And this draft focuses on the OEM mechanisms for network resource partition in MPLS network. Sorry, the slides transition is a little slow. Please, patience.
Is there a problem, Leanne?
No problem, but just the transition is very slow. Okay, this is the second slide. First, I'll start with a quick background of this draft. In the network slicing scenarios, data forwarding quality depends on both path status and the resource status. So at the previous meeting, we presented a draft related to the OEM solution for NRP network. It's in the TIS working group. And this draft utilizes basic OEM mechanisms like pin, tracer, BFD, and stamp to enable the detection of the network resources. And it supports both MPLS and SRv6. So after the presentation, we have received some feedback, and based on this, we separate the MPLS specific parts and formed this draft. And this slide explains how to using the pin to check NRP resource availability in MPLS network. First, for the high endpoint, the MPLS echo request should carry the NRP ID, and each node along the path, including the intermediates and the endpoints, they need to recognize the NRP ID and check if those NRP resources are available. And if the resource is unavailable, the node should reply with an NRP resource and available error message in the echo reply. So here we need to define a new return code in MPLS echo reply. If the resources are available, so the endpoint responds with a normal MPLS echo reply. I think this aligns with the existing mechanism and requires no extension. Another scenario is related to the reverse path as defined in RC 80 and 8029. The return path can be specified by including the reverse path target FCC stack TLV in request message. So based on this, this draft extends this TLV by adding a return NRP ID field. And this will ensure the reply message can also travel back through the specified NRP path. In this scenario, also the end node is required to pass this TLV and obtain the return NRP ID, and then use the appropriate resource of that NRP to encapsulate the data packet. And the specific encapsulation method is out of this draft, and we didn't focus on this mechanism. The tracer is similar as the pin, so involves the same consideration. One is the extension of the error code, and the other is adding the return NRP ID to the reverse path target FAC stack TLV. So I will skip this, the details. It's totally similar. Here are the details for the protocol extension. The first one, we need to apply to ANA for a new error code in MPLS echo reply to represent the NRP resource unavailable. In the second one, we need to define a new subtype for the reverse path target FAC stack TLV to carry the return path NRP ID. Just as the picture shows. This is a practical use case of the pin. I will go through it quickly. So for the successful scenario, the R1 pings R3 using the NRP1, the packet travels successfully along the NRP1 path to the R3, and the R3 will reply with a success. And the failure scenario, just as the right side, the R1 pings using the NRP2, and the R2 checks and finds NRP2 resource unavailable. So it should reply with the NRP resource unavailable error. And this enable faster connectivity checking for the NRP path. Also, the research is much the same. I will skip over it. So that's all the main content of our draft, and we would like to seek feedback from the working group for whether or not this protocol extension is necessary and appropriate. And we also welcome any other question and comments. That's all.
Greg Mirsky Erickson. Can you clarify what your interpretation of NRP available for the transit node?
For example, some channel or some queen, some other things. For example, when we translate the network slicing traffic, we can search first for the routing table to find the out interface, and then we can also further check for the channel or the queue to check if there is the resources for the network slicing. For example, the bandwidth resource, and we think that this progress can be used to check whether or not this resource is available.
So if I understand correctly, you envision that on the transit node and on LSR, there will be a check that checks their status of their resource allocation with the control management plane using the NRP ID. I think that is a major change in how LSP ping processed by the transit node. So I think that would be reasonable to expect that the egress node will do this processing as part of their target FAC verification. But the transit node, I think that really not expected to have this time of verification on the transit node for echo request in the ping mode. Thank you.
One more word. I think this transition is a normal or common flow for the network slicing traffic transition. If any misunderstanding, we can talk further on the list. Thank you, Greg.
Okay, another question, Tarek Saad with Cisco. NRP resources unavailable. Is NRP not supported in scope of that error, or let's say a node doesn't support NRP?
Sorry,
maybe I can ask my question on the mailing list, but need more clarity on resources not available. Thank you.
Okay, okay. Thank you.
All right, I'm Adrian Farrell. For absolute clarity, I am not speaking as working group chair. I am simply an individual that has written a draft. You are very free to tell me that this is a piece of rubbish. There was some discussion on the mailing list that led G and I to write a draft that is a proposal for a survey to determine label stack inspection behavior. This came out of M&A discussions, the interaction between M&A and ELI, but it opens up the wider question of how you process an unexpected, unrecognized, unsupported BSPL or ESPL when it's found in the label stack, when you are looking for a BSPL or ESPL that you do support, or when you are just parsing the stack, for example, to hash it. We looked at 7325 and it's possibly ambiguous. It's probably meant to mean when it's encountered at the top of the stack, but it doesn't say that. So it's possible that people will interpret 7325 to mean when you find it, when you're parsing the stack. So the idea is to see if we can find out what people do today so that when we introduce new SPLs in the future, we won't trip up. So this draft is a working draft of the questionnaire we might send out. It is not the questionnaire, so please don't reply to it, but please do review it to say this is the sort of thing that we would like to find out about. There are some detailed sub-questions to some high-level questions, and we will, when we get to it, ask for responses per implementation to be sent in private to a person who will do the anonymization and then publish the collection. At the moment, we're suggesting that I'm that person, but if that doesn't make you happy or comfortable, then please shout. So as I say, we're not asking for responses to the questionnaire. What we want to do is find out whether this is a questionnaire that's even worth doing, whether it's unambiguous and sufficient, and then if we get it all together, then we can move forward to actually do the questionnaire. Once it's stable, we're not going to go for a working group last call. We're just going to kick it off and then get responses. And I don't propose that we even publish the responses beyond an ID. And of course, it will not be compulsory to respond, and no conclusion can be drawn from non-responses. Tony.
Tony Lee, HPE, chair hat off. I appreciate your intent. However, because this is not compulsory, this is not going to be comprehensive, it may not be accurate, and therefore it feels very wrong to draw any conclusion, and therefore I think we're wasting our time.
Yeah, I appreciate that. And the only thing I can think of is if we got 3 or 4 implementations coming along saying they did something unexpected, then we would need to think. Okay, I'll follow all that up on the list, I think, and see whether we abandon this or what.
Adrian, sorry, I don't know if the queue was locked or not. Was it? I seem to be on.
Oh,
It was.
It was. I was just going to say plus one to what Tony said. I don't think it'll be comprehensive. Maybe we should look at the original text that caused this confusion and say it's adequate, rather than trying to survey everybody, because there'll be lots of things missing. People won't respond because they'll say, oh, it's too much detail about an implementation.
Thank you.
Jason from Huawei. In my understanding, I think this work is will be something helpful for the working group to first identify whether there's any potential issues in the existing implementations. If there's a coexistence of the M&A with existing like entropy label processing. Yeah, that is one point to do this survey. And the second is also during the working mailing list discussion, we noticed that the existing RFC has no clear description about what is the expected behavior when you parse the label stack and find an unrecognized special purpose label. What is the expected behavior? There's no guidance in the existing document, so maybe this is something which need to be clarified in maybe a short document that is also can help to guide the future implementation and the extensions of the special purpose labels, which require you to parse the label stack instead of just parse the top label. Okay, thank you.
Thank you. And now, Shangwan.
Hi everyone. This is Changwang from UHCC. This draft is about the LDP extension for Flash Argo. So background RC 19502 extend the IP Flash algorithm so that it can be used with regular IPv4 or IPv6 forwarding. RC 7307 describe the LDP extension required to support MT routines. RC 19658 describe MLDP extension for MT routines and FA enabled MLDP support for MT and Flash Argo. So in an LDP over IGP Flash Argo network, because the LDP FEC cannot carry the FAID, so LDP is unable to operate based on IGP Flash Argo. So this draft describes LDP extension required to support IGP Flash Argo. Let's see the solution. To support the LDP over Flash Argo, the following three aspects are extended. First, add the LDP Flash Argo capability to negotiate FA capability during LDP label establishment. Second, newly defined an LDP FEC to carry the FAID. The third, we extend the LSP pin to support carry the FAID. The first extension, we define a new FA capability GLV to indicate FA capability support. And LDP speakers can advertise this capability to its peer and to announce its support for FA. The second extension, we extend the LDP FEC to carry the FAID. We define the FA IP prefix FEC and FA IPv6 prefix FEC. When LDP send an FEC, it can carry an FAID. Enable the label location by looking up the corresponding unicast route by the specific FAID. The third extension, we extend the LDP FEC to carry the FAID. When LDP send an FEC, it carried an FAID. The third expansion, we extend the LSP pin carried FAID. We define the new two subtier with FA LDP IPv4 FEC subtier way and FA LDP IPv6 FEC subtier way. These two FEC subtier way at the FAID. During the LSP pin, the FAID can be specified. If no FEC corresponding to the FAID, an invalid FAID error code is returned. Yes, let's all. Any questions, comments are welcome. Thanks.
Kamran is a Cisco system. Can you hear me?
Yes, go ahead, Kamran, please.
Okay. Yes, I'm looking at the draft. I'm actually one of the co-authors of LDP MT RFC. When we added the multi-topology extension, right, we made sure that's backward compatible with the existing FAQ, which were non-MT, and you are adding on top and Flexel Go extensions, and you allow both capabilities to be sent and received, right? Multi-topology capability as well as IPA multi-topology capabilities. I think the document is lacking clarification and procedures in regards to handling on the receive side. If there's a conflict and one writes over the other, is it allowed? Is it not allowed? If it is not allowed, how do you mitigate this? So I suggest that you look into this and add some sections on this.
Okay, thank you. I received your comments. I will consider how to compile this. Thanks.
Okay, thank you. That was our last presentation for today. And I want to reiterate thanking everybody for showing up, contributing to the working group, and we hope to see you again next time. Thank you.